Okay, hello folks. This is the last lesson for this week. It'll be posted Wednesday morning, and then you'll have the rest of the week to complete all the work. And I will again put up a Google form for you to fill out to answer some questions. And I'll explain that at the end of today's little lesson. Again, it's just putting stuff together today. It's just factoring. On Monday, when I post the next thing, that will be review for the unit, and then the next day I will post the online version of the assessment, test, assignment, whatever you want to call it for this unit. And you'll have the rest of that week to hand it in, and then if you don't hand it in by probably Friday, or I don't know, Sunday I guess, I'll call on Monday morning to check in. And obviously I'm going to have to trust that you don't cheat. I've had a few people submit stuff that is just perfect, and then when I look at what they said they've done absolutely nothing. And then other people who've worked very hard will have, a mistake or two. And so I worry about those people who aren't doing any work and are getting it perfect. I mean, that's great if it's real, but if you're just looking up answers, obviously that's not going to I guess that won't be very helpful for you come exam time, assuming we have an exam, or come next year when you really need this stuff and it's assumed that you know it. So please do treat this like any other assessment, and treat this work like any other work. You do need it, and not just for this year. You'll need it beyond this year, whether you stay in the academic university pathway or switch to college. You do still need to know how to factor, and you need to know how to factor well. Okay, so on the screen you can see the first 5-minute question for today. I would like you, as always, to pause it, try it, and then come back. Okay, so hopefully you paused it and tried the question. So remember, step 1 is always to common factor. I can definitely take a 2 out of here. Now, some of you are probably watching me do this and saying, oh, you can take more than a 2, and you're right, I can. But what I'm going to do here is I'm going to pretend I didn't realize that, and I'm going to go from there. So when I take the 2 out, I get this. But now in the brackets, everything's divisible by 2 again. We haven't really had this situation come up. We could have divided everything by 4, but now what I'm going to do is I'm going to take another 2 out of everything, just to show you what happens. So if we take a 2 out, it comes out front, and it actually multiplies by this other common factor, so we end up with a 4 out front. Then we divide each of these by the 2 that was just taken out, and we get 9x squared plus 12x plus 16. Okay, now hopefully you just divided by 4 in the first place, but if you missed it, there's always a way to fix it. That kind of rhymed. All right, now we got to factor what's inside the brackets. There are 2 options here. We can either, I guess I shouldn't have done the brackets yet, but whatever. We can either find 2 numbers that multiply to 144 and add to 12 and then break it up and go from there. Or we can notice, and this is yesterday's lesson, that this is a perfect square. Square root's 3x. And this is a perfect square, which is 4. Okay, and then we can check to make sure it works. So 3x times 4 is 12x. Oh, that's what we have here. But wait, it's supposed to be that we multiply those 2 things together and then multiply them by 2. So this one's actually not a perfect squared trinomial. So I tricked you. I did warn you that I would trick you, and there it is. So instead, let's find 2 numbers that multiply to 144. So A times C is 144, and B is 12. Okay. So 144 divided by 2, that doesn't add to 6. Divided by 3, divided by 4, doesn't work. Divided by 6 is 20. No, that doesn't add to 12. Oh, that should be 7. Doesn't work. Divided by 8. 18 and 8? No. Divided by 9. 9 and 16? No. 10's not going to work. 11? No. 12. Okay, so that doesn't work. because now we've got to the halfway point of 144, the square root. So if we keep going, we're just going to get the other factors, but sort of in the opposite order. So I think that's it. I don't think it factors further. So this is just going to be 4 bracket 9x plus 12x plus 16. Now, if you decided to treat this as a perfect squared trinomial, you would have had 4 bracket 3x plus 4 bracket 3x plus 4. And let's take a look in Desmos, because remember, we can always graph these things, or usually. So 36x squared plus 48x plus 64. Okay, so let me shrink this down. There we go. Okay, so there's that parabola. It's a bit of a crazy parabola, but let's try this. 4 bracket 9x squared, 9x squared plus 12x plus 16. Okay, that's the same, and that's what we got here. But then if you decided to pretend, or if you thought that this was a perfect squared trinomial, you would have this curve. And though similar, is not the same. So that means that this is not the same. Okay, question 2. Again, hopefully you've done it. If you haven't, pause it and try it. Whenever you see two terms with subtracting or a difference, think difference of squares. If both of these are perfect squares, square root of 81 is 9, square root of x squared is x, square root of 25 is 5, square root of y squared is y. If both of them are perfect squares, which they are, this is a difference of squares, and it looks like that. Okay, awesome. So this obviously isn't in your handout. I might start doing that next week so that if you're printing it out, you can have it. But the questions are so easy to copy down. It's just like one little expression. I don't think it's that big of a deal. This next part, though, is not in your note, and that's intentional because I'm hoping that you'll write it down, because I think writing it down will be helpful for you. So we have 5 types of factoring. Common factoring is when all terms have something in common. And you might remember that common factoring is the first step of all factoring. So an example of this would be 5x squared y plus 10xy minus 35 x y cubed. Oh, cubed. Okay, and in this case, the common factor is, oh sorry, this is not a minus sign, so I'm going to fix that. The common factor is, well, we can divide everything by 5. We can take an x out of everything, we can take a y out of everything. So that would be the common factor. We've done that a lot. Again, this is just a quick recap. We'll have a full review period, or a full review lesson on Monday. Simple trinomial factoring. This is when the a value of a quadratic is 1. An example of this would be x squared plus, well, let's make it a little harder than that, minus 3x minus 18. And we need to find two numbers that multiply to negative 18 and add to negative 3. And if we're going to do this one, our numbers would be minus 6 and plus 3. And it would be x minus 6, x plus 3. I'm just going to copy this so the font size is the same. So when the a value of a quadratic is not 1. And an example of that could be, so I just created one, so it would be 6x squared minus 7x minus 3. So I can delete this now. That's just how I make them. I just start with brackets and then I expand. So we first need to find two numbers that multiply to 6 times negative 3 and add to 7. So that's multiply to negative 18 and add to 7. Those numbers are negative 9 and 2. What is happening? Oh, I see. I have like a separate text box within the text box. Now, decompose 7x into negative 9x and positive 2x. Then factor the first two terms and the last two terms by grouping. Finally, factor out the common factor in brackets. And then you're done. Okay, so perfect squared trinomial is when the first term and the last term are perfect squares, and the square root of the first term multiplied by the square root of the last term, and then multiplied by 2 is the middle term. So, for example, we could have 100x squared. Don't write this down as I do it. 21. No, let's do 9y squared. And then in the middle, we would have minus 60xy. So let's try that out. So the square root of 100x squared is 10x. The square root of 9y squared is 3y. 10x times 3y would be 30xy. Times 2 would be 60xy. But because there's a negative in the middle, we do 10x minus 3y squared. Okay, and the last type, and again, this is all a recap, so if you sort of zoom through this, that's probably okay. This is when we only have two terms that are being subtracted, and both terms are perfect squares. Okay, so for example, let's do 49x squared minus 121. So they're both perfect squares. They're being subtracted. The square root of 49 is 7. The square root of x squared is x. The square root of 121 is 11. So 7x plus 11, 7x minus 11. And remember, the purpose of the plus and the minus is that when you FOIL it, that middle term will cancel out because they'll both be the same, but one will be positive and one will be negative. Okay, so there is sort of a recap of factoring. And then in your handout, I've given you a whole big flow chart of factoring. This might confuse some of you. For some of you, it might be helpful. It'll be a good thing to have on hand when you do your assessment next week. Okay, so the next thing that I have in your worksheet, or on your handout, or your email out, or whatever you want to call it, factoring special cases, putting it all together, 2020. All right. All my handouts are a bit different this year. I mean, they're always a bit different, but they're particularly different because now I'm just putting everything in one file, whereas normally I wouldn't. So here's the flow chart, and then what there are is 9 examples. So because this is a factoring day, and just like a sort of put all the factoring together day, I would like you to do these 9 questions. I will talk through these 9 questions, hopefully quickly, and then your homework, on top of some textbook work, will be this factoring formative quiz. So the way this is going to work is stage 1, which is the column on the left. You might need to write this down on paper. There's not a lot of room. You're going to do on your own, and I'm going to post the solutions. I'd like you to check those solutions and then try stage 2. I will post the solutions to stage 2, okay? And you check your solutions. And then stage 3, I'm going to send you as a Google form, and I want you to put your answers in that, and that will be your assessment for this week. And just like last week, I will get back to you with some feedback about how you did. Okay? And I won't be counting this for marks, but it'll be a good way to see where you're at. Okay, so I would like you to pause now and do the 9 questions on the second page of your handout. So please pause now and do those. Okay, hopefully you tried them. First one, we can common factor out a 3 and a d, and we're left with d minus 3. The next one, 2 terms subtracting, they're both perfect squares, 2x plus 3, 2x minus 3. The third one, it's a simple trinomial, so we need 2 numbers that multiply to 24 and add to 10. So 1 and 24, no. 2 and 12, no, because they're all positive. 3 and 8, no. 4 and 6, so x plus 4, x plus 6. And if you wanted to say the zeros for these, here it would be 0 and 3, negative 3 over 2 and 3 over 2, negative 4, negative 6. But that'll be more of a Monday thing. Today's just straight up factoring. This one I can first factor out a 2, 4x squared plus 12x plus 9. Now I notice that these are both perfect squares, the first and last term in here. This is 2x if I take the square root. This is 3. 2x times 3 is 6x. And if I double it, I get 12x. So this is 2x plus 3, 2x plus 3, or 2x plus 3 squared. This next one, you're going to be really tempted to just be like, oh, it's a difference of squares. But you can common factor. So first, take a 4 out. And you get a squared minus 4b squared. Now in the brackets, those are still perfect squares. The square root of a squared is a. The square root of 4b squared is 2b. So a plus 2b, a minus 2b. If you did not common factor first, you would have had 2a minus 4b, 2a plus 4b. And then if you had that, you would have noticed, just in this one bracket even, these are both divisible by 2. Okay, so that means you should have common factored. Okay. And then you would have taken a 2 out of that bracket and the other bracket. It would have got really messy. So common factor first. Okay, next one. Again, there's a common factor of 4. If it feels like I'm going really fast, you can slow it down. You can watch them again. But remember, the idea here is that this is review from the week and last week. And the other idea is that you already tried these. So if you're watching this without doing it, I think you should stop and try the questions. There's only really 3.5 left. Okay, so now it's a simple trinomial in brackets. So 2 numbers that multiply to negative 10 and add to 3. 1 and 10 doesn't work. 2 and 5 does. Because it multiplies to negative 10, I've got a positive and a minus. It adds to a positive, so I've got more positive. And there we go. Next one, oh, it's a complex. So a times c is 3, b is 4. 2 numbers that multiply to 3 and add to 4. This is the kind of question that I find a lot of people, just checking on my equal signs, I'm all good. This is a question that I find a lot of people screw up because they forget that 1 and 3 multiply to 3. So plus 3n plus 1n plus 1. I can common factor 3n out of the first term. I'm left with n plus 1. And the only thing I can take out of these is 1. I'm left with n plus 1. And I get n plus 1 times 3n plus 1. And of course, you can FOIL that out and double check. So here again, I can common factor. So 2d squared minus 5d minus 24. Now I need 2 numbers that multiply to negative 24, because it's a simple trinomial, and add to negative 5. Those numbers are 3 and 8. But I know that I'm going to have a positive and a negative because it multiplies to negative 24. And I know that it adds to a negative, so I got to have more negative. And I think that should work. The last one, I really hope you've seen the theme that common factoring is a massive part of this stuff. So the first thing I'm going to do is find a common factor for these. And I believe 3 divides into both. And it does. So I can take 3 out. And I have 16x squared minus 25y squared. Now, can I factor that further? I have 2 terms, and they're subtracting. If they're both perfect squares, it's a difference of squares, and they are. The root of 16x squared is 4x, and the root of 25y squared is 5y. In a question like this, where there's two letters, x and y, I would never ask you for the zeros. It just doesn't really work. Okay, this would be like a three-dimensional situation or something, and not something I would want you to deal with, or maybe it could be a circle, I don't know. But I wouldn't ask you for the zeros. If I asked you for the zeros here, they'd be -3 and 8. Here, they'd be -1, -1 over 3. The zeros here would both be -3 over 2. Again, two letters, so I'm not going to ask you for the zeros. And here, -5 and 2. Okay, so that's it. It was 20 minutes. It always goes at least 20 minutes. I can't make it any faster than that, but if you increase the playback speed, 10 minutes is not too long. So that's it, folks. Again, please try column 1, check your answers, column 2, check your answers, and then column 3 I will post as a online assignment around noon on Thursday. And then I will send you another thing on Monday. Have a good weekend, and check in if you have any troubles. Good luck, folks.